Okay, two IB students carried out the project on a chemistry on bleach. Bleach is this. They're trying to work out this. I'm just skimming a question. The bleach was first diluted to that, and then you got this reaction going on, and blah blah blah. So we've got a titration. We put this stuff in, and initial readings are there. So we've got 23.95. So that's the reading there. 23.95. Calculate the volume in centimeters required to react with iodine to reach the end point. We've got sodium thiosulfate here reacting with iodine. Alright, so we've got 23.95 here, and then we have to work out what the others are. So we better do that down here in the box, because that's the only place it'll count. Calculate the volume in centimeters cubed. Alright, so the first titration here is going to be 23.95 minus 0 equals 23.95, and then the second attempt will be 46.00 minus 23.95. So do that in the calculator, and that's 22.05, which is a fair bit different. Alright, I've got titration videos there available if you want to see how to do it and why that's wrong, which I made just for IB. The third one here is 22.15. Oh no, we started at 0, yeah, minus 0, and that's 22.15. Now, both of those are not brilliant. You should be within plus or minus 0.05, but this really is your rough, and so we ignore it. And so what you want to do is get an average of those two, and there's 10 difference in there, so I could do that in a calculator, but the average will be halfway, so it's 5-way each. So the average is 22.10 centimeters cubed. So that's the amount of that's the answer that we're looking for. And I just better write, make it clear and label things. Okay, part 2. Calculate the amount in moles of sodium sulfate that reacts with iodine. And so concentration equals number of moles on volume. So the number of moles equals concentration times volume. Now we know the concentration from the top as 0.1. So we have 0.1 moles per decimeters cubed, and we just worked out from the previous one that it's 22.1 centimeters cubed, so that's converted to decimeters cubed, so it's 0.0221 decimeters cubed. And we get a calculator out, and we get 0.00221 moles of sodium thiosulfate reacting. Okay, the next step, calculate the concentration in moles per liter of hypochlorite ions in the diluted bleach solution. So what actually happened here? So bleach solution contained these ions. It was diluted 1 in 10, so they took 25 mils and put it in there. So that's what we did with deionized water, and then we've reacted it with iodine, 25 mils of that solution. So the initial solution that we've just worked out there as 0.00221 moles was contained within 25 mils, and so that there was the aliquot that we took into 0.025 decimeters cubed. Okay, next is calculate the concentration in moles per liter of the hypochlorite ions in the diluted bleach solution. And so we had this amount of moles react here in 25 mils of the bleach at 250 as a total of 250 centimeters cubed, and so we've worked out here 0.0221 moles here. Now that would have reacted the sulfate with the iodine, and so that stoichiometry is 2:1, and that iodine there is going to react with hypochlorite, and that is 1:1. Okay, so that's the stoichiometry. So for every 2 molecules of this, it's going to react with 1 molecule of that via iodine, and that's just 25 mils. It's been diluted in 250. So we won't work out the final concentration of chlorite till the end, hypochlorite. So calculate the concentration of hypochlorite in the diluted bleach solution. So 1 ml of hypochlorite is 2 moles of Na2S2O3. So X is to 0.00221 moles. We cross multiply there, so 2x equals 0.0021 moles, and so therefore X equals 0.00221 on 2. So that's the number of moles of ClO minus. Now we want to have the concentration, so concentration is equals number of moles on volume. So we have 0.00221 on 2, and that there is divided by the volume, and so the volume of this thing was undiluted solution was 25 mils that was taken out, so that's 0.0025 decimeters cubed. So this is the number of moles that we worked out, and this is the the volume to point there. So if we plug that into the computer, we get a final reading of 0.0442 moles per decimeters cubed. Finally, calculate the concentration of hypochlorite ions in the undiluted solution. So this, we've worked out the concentration of the 25 mils, and we know that we had originally we had that 25 mils was actually diluted 1 in 10 with a 250 mils. So there's several ways to do that, but you don't have much room here. So we might try the C1V1 equals C2V2. So the original concentration is what we're after here, and the original volume was 250 mils. So that's 250 decimeters cubed. And the concentration worked out the top up there was 0.0442 moles per decimeters cubed, and that was only 25 mils. So the original concentration, if we do the sums on that, divide both sides by 0.250 decimeters cubed, we get a final answer. We get a final answer of 0.442 moles per decimeters cubed. The other way to look at that was just to see that that was diluted 1 in 10, and you could just grab that final number and times it by 10.